Welcome to the session on data collection, sampling. The objectives for this session are to understand the advantages and disadvantages of various sampling methods, such as simple random sampling, systematic sampling, stratified sampling, quota sampling, and opportunity sampling. In statistics, a population is the entire set of items which are of interest. In random sampling, every member of the population has an equal chance of being selected. The sample should aim to be representative. Random sampling helps remove bias from a sample. Let's take a look at simple random sampling. A simple random sample of size n is one where every sample of size n has an equal chance of being selected. The methods of random sampling are simple random sampling, systematic sampling, and stratified sampling. To obtain a simple random sample, a sampling frame is needed. Then there are two methods of choosing the sample: generating random numbers and lottery sampling. So how do we generate a sample? Let's take a look at a sampling frame and sample selection. Remember that a sampling frame is when sampling units are numbered to form a list. When we can do this, we allocate a number to each member of the population. So here's our population. Our population has size 20, and we require, say, a sample of size 5. This is the process that we're going to use. First, number each member of the population, as shown. Next, generate random numbers to the required sample size. So in this example, we could generate 5 random numbers between 1 to 20 using our calculator. The numbers which we have been given are 20, 9, 17, 5 and 18. So let's select the corresponding members. Here's the 20th member, the 9th member, the 17th member, the 5th member, and the 18th member. What is lottery sampling? Let's take a look at an example. Write the names of the sampling frame on individual cards. Our population has size 20, and again we require a sample of size 5. Let's take a look at the selection process. First, write the names on individual cards, as shown. Then, place the cards in some kind of hat or container, as shown. And then, draw out the relevant number of cards to the required sample size. So name 7, name 15, name 4, name 3, and name 12. Let's now take a look at some of the advantages and disadvantages of simple random sampling. So advantages first. It's free of bias. Its implementation for relatively small populations and samples is easy and cheap. And every sampling unit has a known and equal chance of selection. And now for the disadvantages. It's not suitable when population or sample size is large, and a sampling frame is needed. And now for systematic sampling. In systematic sampling, choose the required elements at regular intervals from an ordered list. So, let's take our list of people. Our population has size 20, and we require a sample of size 5. How do we select this using systematic sampling? So the sample selection process is as follows. First, calculate 20 divided by 5. This is the size of the population divided by the sample size we require. So 20 divided by 5. And this is of course equal to 4. So we select every fourth person from our list. And the following people will be selected. Person 4, person 8, person 12, person 16, and person 20. We could select a different sample if, for example, we were counting horizontally rather than vertically. So here's person 4, person 8, person 12, person 16, and person 20. Now let's take a look at some of the advantages and disadvantages of systematic sampling. So the advantages first. It's of course simple and quick, and it's suitable for large populations and samples. And some of the disadvantages are that a sampling frame is needed and bias can be introduced if the sampling frame is not random. Let's now define stratified sampling. In stratified sampling, the population is divided into different strata and a random sample is taken from each. The strata must be mutually exclusive. So let's take a look at some examples. We could have part-time and full-time workers in a factory, or male and female students. We now take a look at the formula for stratified sampling. The number sampled in a stratum is equal to the number in the stratum divided by the number in the population multiplied by the overall sample size. Let's now take a look at an example. A factory manager wants to conduct a survey of how the staff find working conditions in his factory. He decides to give a questionnaire to a sample of 60 workers. It is supposed that part-time and full-time workers are likely to have different opinions. There are 300 workers in the factory, of whom 200 are full-time and the rest are part-time. A. State which method of sampling the manager should use. And B. Explain how he could use this method to select a sample of workers. So let's consider part A first. Of course, if we're looking at part-time and full-time workers, then they're likely to have different opinions, as has been stated as part of the example. So therefore, the manager should use stratified sampling. And now for part B. The manager should find the number of workers required in each subgroup, i.e. using the stratified sampling formula, then use random sampling to select the workers. So let's apply the stratified sampling formula to our example. Here's our table. We have 200 full-time staff and 100 part-time staff, and a total of 300 staff. The number which are required in our sample is 60. Therefore, the number of full-time staff required in our sample is 200, which is the number in the stratum, divided by the number in our population, which is 300, multiplied by the overall sample size, which is 60. And calculating this gives us 40, so there will be 40 full-time staff in our sample. And now for the part-time staff. How do we find the sample size for part-timers? We have 100, which is the number of part-time staff, divided by 300, which is the total in our population, multiplied by 60, which is the overall sample size. And therefore calculating this gives us that we're required to have 20 part-time staff in our sample. Notice that the total of full-time and part-time staff adds up to 60. Now let's take a look at some of the advantages and disadvantages of stratified sampling. So advantages first. The sample will accurately reflect the population structure. It will also guarantee proportional representation of the chosen groups within the population. However, the population has to be clearly classified into distinct strata, and it's not suitable when the population or sample size is large. Furthermore, again, a sampling frame is needed. We will now take a look at non-random sampling. A non-random sample of size n is one where every sample of size n does not have an equal chance of being selected. The methods of non-random sampling are quota sampling and opportunity sampling. Let's take a look at quota sampling first. In quota sampling, a researcher or interviewer selects a sample reflecting the characteristics of the whole population. So here are its stages. First, divide the population into groups according to given characteristics. The size of the group will determine the proportion of the sample having the characteristic. Now the interviewer meets the people, assesses the group, and post-interview allocates them into the appropriate quota. Here is where interviewer bias might come in, and it becomes a non-random process. This will continue until the quotas are filled, and then move on to the next person if we have a non-respondent until the quotas are complete. Now let's take a look at the advantages and disadvantages of quota sampling. So the advantages first. Quota sampling allows a small sample to still be representative of the population. It is simple, inexpensive and quick. And no sampling frame is required, though it can be used. It also allows comparison between different groups within a population. And now for the disadvantages. Non-random sampling can introduce bias, and interviewer bias in particular, as we mentioned earlier. Bias can also be introduced if the sampling frame is not random. Furthermore, increasing the study scope increases the number of groups, which of course means time and money. And finally, non-responses are not recorded. This can be crucial because non-responses may occur for a vital reason. And now for opportunity sampling. In opportunity sampling or convenience sampling, we take the sample from people who are available at the time the study is carried out and who fit the required criteria. So, for example, the shoppers leaving a department store between 9 AM and 10 AM on a Thursday morning. Let's now take a look at the advantages and disadvantages of opportunity sampling. So the advantages are that it's very easy to carry out and relatively inexpensive. The disadvantages are that it's unlikely to provide a representative sample, and it's highly dependent on the individual researcher. This brings us to the end of this session. If you have understood its contents, you should be able to understand the advantages and disadvantages of various sampling methods, such as simple random sampling, systematic sampling, stratified sampling, quota sampling, and opportunity sampling. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.